Welcome back, everybody. In this video, we're going to be continuing with section 9.1, working with two proportions. So where we'd left off was we had done this hypothesis test about the proportion of smokers in Alabama versus Missouri. And we ended up rejecting our null hypothesis and concluding there was enough evidence to support this claim that the proportion of adults who are smokers is lower in Alabama than in Missouri. And so what I wanted to do next was use that same story to give us another example of a confidence interval estimate. So for this one, we want a confidence interval estimate of the difference between the two population proportions. So the ingredients we're going to need for this are the Z alpha over 2, and then basically the P1 and P2 hats. And then N1 and N2, which is our two sample sizes. The two sample sizes were both 2,000. Okay, so let's go ahead and get started with this then. So our Z alpha over 2 we're going to need. And so here we need to think about what confidence level is appropriate for this. So in the test that we had done, it was a 0.01 test. And so remember that that would be in one tail. So for a confidence interval, we would need 0.01 in each tail. So that's 0.02 altogether, or a 98% confidence interval. For a 98% confidence interval, the critical value is 2.33, which you can obtain from our standard normal table. Okay, so then the next thing that we want to think about is the difference of those two sample proportions, because we're going to want that as well. And so that is negative 0.04, sorry. Okay, and that's obtained just from subtracting these two P1 hat minus P2 hat. Okay, so then let's go ahead and calculate our margin of error next. So that will be our 2.33. We're multiplying that by this nice big square root P1 hat times its complement, which is Q1 hat. And that was 0.753. That's over 2,000. And then we'll have 0.287 and its complement, which is 0.713. And that's also over 2,000. Okay, so let's go ahead and compute that. All right, so for the margin of error, I'm getting about 0.0326. So then we'll get, for our left end of our confidence interval, P1 hat minus P2 hat minus our E. And that is about negative 0.0726. Okay, and then we'll add that. And that'll be negative 0.0126. I think that seems okay. All right, so then that's our interval for our difference of our two proportions. All right, so I just wanted to rewrite some of my notes here, just making this a little neater. And also I found a arithmetic mistake I had made in doing the subtraction. So that's been repaired also. So the interval runs from negative 0.0726 to negative 0.0074. So again, we're pretty confident that our difference P1 minus P2 is negative. And so if P1 minus P2 is negative, P1 minus P2 is negative, then that means the same thing as saying that P1 is less than P2. Okay, so that's it as far as finding our confidence interval and interpreting it goes. Okay, so that's the end of our example. All right, so here is our next example. The story is that a survey of 977,000 students taking the SAT revealed that 11.7% of the students were planning to study engineering. And then in a recent survey of 1,085,000 students taking the SAT, 8.5% were planning to study engineering. We want to study or construct a 95% confidence interval for the difference in proportions. Okay, so take a few minutes and see how far you can get in setting this up, and pause the video and try this yourself, and then restart the video and see how far you've gotten. All right, so this is what I've got so far. I've decided just to call the first population, so our P1 will be the first group mentioned, which was the 977,000 students in the first study. And the second group is the 1,085,000 students. We'll call that the second population. So then 11.7%, that is basically our P1 hat, 0.117. Our P2 hat is 0.085, and that corresponds to the 8.5%. Since it's a 95% confidence interval, that corresponds to a Z alpha over 2 of 1.96. Okay, so what we're going to do next is find the P1 hat minus P2 hat. Okay, and that won't take long at all. But what will take a little bit longer is finding that margin of error E. So again, pause the video and see what you can get done from there. All right, so this is how this plays out. Going through all the calculations, again, our Z alpha over 2 is 1.96. We had our P1 hat times our Q1 hat, which is the complement of the P1 hat. So 1 minus 0.117 is where the 0.883 came from, divided by our sample size, and then similar structure for the one on the right. We had our second P2 hat and then Q2 hat, and then divided that by the sample size. Add them up, take the square root, and we ended up with 0.0008 approximately. Okay, so then we're going to take our P1 hat minus P2 hat minus the margin of error, and that will give us 0.0312. And then P1 hat minus P2 hat plus our margin of error will give us 0.0328. So then our confidence interval ends up being 0.0312 is less than P1 minus P2 and up to 0.0328. So that is a fairly narrow confidence interval, and I think it's due to the fact that we had such a large sample size. You can tell these big denominators make it so that our margin of error E is relatively small. Okay, so that's it as far as that goes. You'll notice that it is positive between the two. So that's, to me, pretty suggestive that P1 minus P2 is greater than 0, or that P1 is bigger than P2. Okay, all right, so that takes care of that example. All right, so this will be our last example. The story goes like this. In Cleveland, a sample of 73 mail carriers showed that 10 had been bitten by an animal during 1 week. In Philadelphia, a sample of 80 mail carriers, 16 had received animal bites. We want to know if there's a significant difference in the proportions. We're going to use an alpha of 0.05. It says find the 95% confidence interval for the difference of two proportions. So let's go ahead and do that. We're going to do both the hypothesis test and the confidence interval. So let's actually do the confidence interval first. So I want to change part of the problem 1 second. All right, so I was originally going to change the problem, but I decided to go with it as is. So I've set it up so that Cleveland will be population number 1 and Philadelphia will be population number 2. And our null hypothesis is going to be that the two proportions are equal. So the way that it's stated is it says, is there a significant difference in the proportions? So it doesn't say one side or the other. So we're going to do this as a two-tailed test, partly also because we haven't had one. So we're going to do this as a two-tailed test. So our alternative hypothesis is that P1 is not equal to P2. Okay, so let's go ahead and do that. So we're going to do the hypothesis test first. So let me do a little sketch. So this thing is going to be a two-tailed test. And since our level of significance was 0.05, that means we need 0.025 in each tail. Okay. So that means if we have 0.025 in each tail, that's 1.96 for our two critical values. Okay, so then the next thing we're going to need is the all of the ingredients for our test. So that will be our P1 hat. Okay, that is 10 out of 73. Okay, we'll get a decimal in a minute. We'll have P2 hat. That is 16 out of 80. And that is 0.2. Okay, and so 10 out of 73. That's 0.13, let's say 0.14. Okay, so let's see about putting together the rest of this into a test statistic. So pause the video, see if you can put that together, and then restart the video and see how you did. All right, so going through the details, the P1 hat was 10 out of 73, or about 0.137. P2 hat was 16/80, which is 0.2. We need the pooled proportions, so P bar, which is 10 plus 16 over 73 plus 80, that works out to be 0.1699. And then putting it into our test statistic, we get 0.137 minus 0.20. That was the difference in our P1 hat and P2 hat. Our hypothesized difference, as always, is 0. We're dividing by the P bar Q bar times the sum of the reciprocals, the two sample sizes, and we ended up with a test statistic of negative 1.04. So where that is a negative 1.04 is not in our rejection region, and so based on this, we're going to fail to reject our null hypothesis. And so that's, we could say that there's not significant evidence to support a claim that the two proportions are different. So one was about 13%, one was about 20% basically, but at the 0.05 significance level, we haven't found a significant difference. Okay, so that takes care of our look at it as a hypothesis test. Let's see about constructing a 95% confidence interval and see what we get. So pause the video at this point and start to construct that 95% confidence interval, and then restart the video and see how far you've got. Right, so this is the start. So I'm going to need the difference between the P1 and P2 hats. That works out to be about negative 0.063. And then we've got our formula. Our Z alpha over 2 is going to be 1.96, since we're constructing that 95% confidence interval. Our P1 hat was 0.137. And then our Q1 hat will be its complement. So that's 0.863. And that's divided by our first sample size, which was 73. Our second P2 hat was 0.2. And so our Q2 hat is 0.8, and then our other sample size is 80, right? Yeah, it was 80. Okay, so then let's go ahead and calculate what our margin of error is. All right, so our margin of error ends up being 0.118. So then if we take our negative 0.063, the difference of the two sample proportions, and subtract the 0.118, we'll get negative 0.181. And then if we add the 0.118, we'll end up with 0.055. Okay, so then our 95% confidence interval is from negative 1.181 up to 0.055. So that is our confidence interval, and you can tell that we wouldn't be able to support a claim of a difference in the two proportions, because the difference P1, P2, that interval, it has a meaningful, well, I didn't want to say significant, a meaningful part of it is on the negative side and the positive side. So looking at this, If I told you that P1 minus P2 is between negative 0.181 and positive 0.055, would you be convinced that it was either positive or negative specifically? And I think most people are going to say no. So that is consistent with what we got before for the hypothesis test, that there was not that significant difference. Okay, that takes us to the end of our example. And that also takes us to the end of section 9.1 as well. So in section 9.2, we're going to be doing materially the same thing as we were here, only instead of statements about two proportions, we'll be making statements about two means. So if you've got two populations and you've taken two samples, can you say the mean of one is higher than the mean of the other, or lower, or maybe not equal? We'll be doing hypothesis tests for the two means and also be taking a look at confidence intervals for the two means. Since we're working with means, again, we're going to, depending on criteria we'll talk about then, we'll be using maybe the Z table, or we might be using the T table, as we saw in chapters 7 and 8. So that's the end, though, for section 9.1. Let me know if you have any questions, and then have a great day.